couple of presentations already. This is our last one, it's about programming, which I guess gets a lot of attention by people who are, your builders or just people around wondering like what we do and all that. My presentation is not really going to be on the basics of programming. I kind of wanted to do something a little bit more out there that would kind of show you some things that you can start working towards in the future, hopefully, and all of that. So I'm just going to show a little demonstration of our own robot working, and grab a little cable here to plug it into the projector. But our robot uses a program called OpenCV to detect the blocks during the autonomous period. OpenCV is just a camera vision thing. As you can see on the front of our robot, we have this little camera. And the webcam tells us data back in RGB values, which stands for red, green, blue. And we can use that data just to directly implement our own algorithms on the program and do all sorts of things. There we go. So that's our robot. I'm sure you've seen it plenty of times. For the control hub, you have to actually plug in an HDMI cord in order to see this page, which is really interesting. But I'm going to run our little test here. Our test program. Here, it is lined up correctly, just so you know that. Seeing things in the background. Alright. So this isn't the exact lighting of the competition. And all those little squares over there you can just ignore because I've never seen that happen on the field before. But this program will basically outline our team marker. It'll also outline any blue squares or red squares that look like the other two placements for the ducks. And so the goal of that is that we can identify the barcode area and actually figure out where our team marker is placed, compare it to the other two squares, and then we get where it is, and we can put the preloaded block on the right level of the line shipping. As you can see, this program is actually pretty accurate. It's drawing the green line around what it thinks is our team marker, and then it's outlining it with this box here. So, and it would function better if there were two blue squares next to it like it's supposed to. I can rotate this square a bit. We'll just follow it around. And that's called OpenCV, which is a program that's not actually preloaded into the FTC library, but it's super cool. I just wanted to show that to start off. With that program, we can identify the alliance shipping hubs, so we can identify those little squares and the boxes for the depot things. Actually, we can identify every object on the entire field if we program it to. But I'm going to show you a program about TensorFlow. Have any of you heard of TensorFlow before? Okay, a few of us. TensorFlow is a really great program for starting off camera technology like this because it allows you to just, it basically just detects objects on the field without you having to do your own code for recognizing like raw data from a camera, which is what we do. TensorFlow is preloaded into the FTC library, so you don't have to do anything. There's a sample project on your computers. And I'm going to show you how to open that up right now. All right. So here's my code here that I just got started working on for TensorFlow, which is a program we can find in our samples. In order to get this program working, I just went and popped open a new tab, new program thing, and I went to a sample and found TensorFlow object detection webcam. The importance between these ones is obviously this one is for a webcam, so you have a hardware configuration for this webcam right here. Ours is just plugged directly into the control hub, which is really nice. If you have an expansion hub, you can plug it into the phone, I think, in a certain way. There should be a way to split the connection between your expansion hub and the phones. But I would really recommend using a webcam if you want to learn about detecting objects, because they have a lot better resolution than your camera's phone thing. They can detect things from a lot further back. So if you're really interested in learning about this, you should definitely look into investing in a webcam. I'm just going to cancel it. Here is our program. I'm going to explain a little bit of what's going on here. So in concept TensorFlow object detection, it's going to actually pull a file out of here that has a bunch of pictures of these objects and the ducks and the spheres and the other markers around the field. And the goal of the TensorFlow is that it has so many pictures it compares these to that one of them is going to look somewhat close to this, so it can identify it as a cube. Right, so that's what we're loading here where it says cube like 5. We scroll down just a little bit more, we get this Euphoria key. The Euphoria key is really easy to obtain. Just type it in, search it up, and you can make an account and get a free key, a developer key. And it explains here in the sample how you can do that. And scrolling down here, here is our code for detecting an object using TensorFlow, which I'm going to play this code pretty soon as well. But you might notice it's kind of, well, there's a lot there. Says if upload is active, that's just everything you start with a normal Java program is saying, well, is our robot running right now? Right? And then we're saying, is TensorFlow basically working? If it's not working, it's going to return null, which just means nothing. It doesn't really exist. And then we're going to look for updated recognitions, because the way TensorFlow works is it sees if there's any changes between the previous frame, right? In a video frame, you get one frame, and then it will scan through that frame in our updated recognitions and give us any new data, instead of just giving us data every single time, which would be a lot for our camera to be able to handle. Objects detected is going to go into here as a basically just saying our updated recognition size, which is how many new things have we gotten. And that's going to display into our telemetry. And the rest of it is pretty basic. It's actually, if you scroll through here, I think this is something that any team could implement once you start working on Java. It seems really boring, but it's not. This is all initialization stuff, which is just, you do it once to start off the program, and you never rebuild that again. It doesn't actually have any really practical use to like memorize it or understand what it's doing. It's the same thing with this. These functions are called here. That code is brought up here. It's simplified for us. So that's all for how that runs. And I'm going to switch us back to seeing what that does exactly. should tell us. I'm not entirely sure if it's going to actually select us. Yeah, TensorFlow is a little finicky with things. There we go. That is obviously not our cube that is selecting right there. This is why I like OpenCV a lot better, because TensorFlow uses a lot of data to process things, like this cube. But it's not always super accurate. It's close enough that if you got this, you'd be able to figure out where the cube was. The computer's only 87% sure that that's actually a cube. That's what it's telling you, which is, I think, kind of funny. Yeah, we'll do that for the ducks too. So we got a duck in here. We could put it up here, and it would detect it. So that's something you can use pretty easily for your program to run. Yeah, I'm definitely a fan of using cameras and technology. Does anybody have any questions about using cameras? I know there's a lot out there. Yeah.
So all of this can all be achieved by just opening a sample program, right? So it's like nobody has to actually really program it. They can just understand how it works and put it in before it and just run.
Yeah, exactly. And that's one of the main points I wanted to make here is that all of this is available to you with comments about how it works on mock Java. All you have to do is click make a sample, and it's right there. Like I said, I would encourage you to use the webcam if you have a webcam, but if you don't, you can use your phone's camera on it. And yeah, it's all set up and ready to go.
So have you taught Vuforia to recognize your own item? Or is that why you're using the CV instead?
Yeah, we use OpenCV to recognize our own. We programmed that. And I can show a little bit of that program as well. It's a little more complex because OpenCV, it uses it just gives you back the raw data from the camera, which means each pixel on your screen, it tells you the red, green, blue value, like I was talking in the very beginning. And we made a program that would select the edges around things that had different or just dramatically different RGB values. And that got us pretty good results. So, yeah.
So with your initialization in there, you see the square in the middle?
Mm-hmm.
That's all it's looking at. It's not really considering the stuff that's ghosted. It's too zoomed in. So if you adjust the code and back out your zoom, it probably will do better.
Yeah.
The more the camera sees, it has a harder time detecting things. So you got to find that good balance of a good zoom.
Yeah, you're right. And so I think this comes with a pre-initialized zoom. But I just made this program 20 minutes before that, so it's pretty good. I have to say that's the power of having the samples on here. And he's completely right too. And I'm sure that this could be a good zoom for your field. It probably is about what you want, or probably larger, maybe larger width. But those are things you can do is cut out areas you don't want it to look into and get random jump from. Yeah. Any other questions?
Yes. Okay, so is the cam useful for both autonomous and teleoff, or do you use it more for autonomous?
It can be useful in teleoff, and the reason is because if you want to use the image to locate everybody noticed that there's images on the walls of the field. Those can be used to locate where your robot is on the field. If you want to find its position, you have to be really precise about how we did it. And we were kind of experimenting. We never got to really get around to it, but we wanted to experiment with 2 webcams so we could triangulate our location from those, because it's not super accurate to get location from one. But yes, it can be helpful in both autonomous and teleoff. We also have a program that detects the Alliance shipping hub. So that's helpful for us if we want to, in the future, just have a robot automatically drive to the spot where the Alliance shipping hub is. Yeah. I think it's been pretty accurate. I think it's worked really well for us. I saw that when I used this thing, it put an outline around it, using the edge detection. And I found it actually works a lot. It works better than how it was at the close to the range. So if I made it, I take it back a bit, then it will always find this. I've never had it not find this.
So which one is more customizable? Is it TensorFlow or is it OpenCV?
Definitely OpenCV. And there's actually 3 programs out there. There's Euphoria, which is just image recognition, so you can locate those image things on the field. Or in the SkyStone series, you can locate images on the SkyStone. That's good. It's a little faster than TensorFlow. TensorFlow is slow, it has a lot of data process. And then OpenCV, I feel like is faster than TensorFlow as well. And it's a lot more customizable because you write your code. You basically write everything you want it to do. So yeah. And yeah, I think I'll show a little bit of code here for my OpenCV program. I apologize for the screen size. It was small here. By the way, OpenCV takes this, it takes an external library that you have to import in on.java, which is not super difficult. It's just, you just drag and drop it basically, or upload it with this. And you can look it up on the EasyOpenCV library for FTC. Will give you this library, which is pretty nice. So, let's see. As you can see, I'm also using a multi-file system, which is really good for organization. It's been that helpful for me. This is my protection program. So all I do basically is this is my input frame that gives me all my RGB values. And I take them, convert them into HSV values, which is the hue, saturation, and anyways, it's brightness kind of like thing, but I never use that one anyways. I basically stick to using hue because that's what's going to give you your colors, and really differentiate most of the objects on the field. I'm using this plain edge detection thing. There's not a lot of work I have to do to use that. It's really good for when it's in motion as well. Seems to have been very accurate in keeping this one with the shape, even if I'm moving the webcam around. And then there I just draw the bounding rectangles around it. And then here I'm sorting, I have to take the rectangles, I've made bounding rectangles, and I've averaged the color inside of them to figure out which one is red and orange, which is marker, which one's like red or blue, which are the 2 squares around it. And so I'm averaging the color inside my bounding rectangles, finding out which one's closest to it and sorting them so that I can identify what position it's at and output this block position back to my program. Which is actually this program right here. And this program, I initialize everything, and yeah, I just give this, I just call this the pipeline from here. And that's all there is to it. Which is, there's a lot there to see, but I just like for you guys to know that this is out there to create, like it's not a software that's actually extremely difficult to use, like it looks. It's a very useful software. Very useful library, and it's practical. And it didn't take me a super long time to mess around with all the variables and things like that. Yeah, that's all I have.